Hello everyone, I'm Aman Gandotra and I'm really excited to showcase my project Find My Book, AI and IoT Smart Library, Navigation and Inventory System. This project is developed for Smart Home and Wearable Project Contest 2025 organized by Circuit Digest. Before getting into the technical details, I would like to take a moment to express my sincere gratitude to DigiKey for supporting this project by providing the ESP32-S3 Box 3, which acts as the core controller of the entire system. I am also thankful to DigiKey and Circuit Digest for giving me this wonderful opportunity to build, learn, and showcase an idea that focuses on solving a real world problem. The idea for Find My Book came from a simple observation in my college library. I noticed that students often spend a lot of time just trying to find a particular book. Even when the book is available, looking the correct rack, the correct row, or the correct position becomes confusing and frustrating. Most libraries still rely on manual labeling systems, which are not only difficult to maintain but also prone to errors. Books are frequently misplaced, records are not updated on time, and in many cases, there is no reliable system to prevent unauthorized removal of books. So, to address these issues, I came up with Find My Book, a smart solution that combines IoT, RFID, and automation to make library navigation and inventory management faster, smarter, and more reliable. For this project, I have used an ESP32-S3 Box 3, a Raspberry Pi equipped with a 32 GB micro SD card, RFID tags and RFID cards, along with an RFID reader module, and multiple ESP8266 microcontrollers, and a few meter long WS2812B addressable RGB LED strips. Now let me take you through the section 1 physical model and hardware overview of the components used in this project. This model represents a miniature version of a smart library. It contains 16 different types of books and each book type has 4 copies, making a total of 64 books in the system. Each book has small RFID tag embedded inside it. This RFID tag gives every book a unique identity, allowing the system to track its availability, issue status, return status, etc. Moving on to the racks, the system consists of two book racks named Rack A and Rack B. Each row in these racks is equipped with WS2812B addressable RGB LED strips. These LEDs play a very important role in navigation. When a user searches a book, the system automatically highlights the exact row, exact column, and exact rack using these LEDs, guiding the user visually to correct location. These racks are controlled using custom designed PCBs that house ESP8266 microcontrollers. These microcontrollers receive commands wirelessly from the central system and control the LED behavior in real time. At the entry and the exit point of the library model, there is an RFID scanning system. Whenever someone tries to take a book outside the library, the system checks whether the book is issued or not. If the book is not issued, the system will immediately detect it and will trigger an alert. This feature helps in preventing book theft and ensure that the inventory data always remains accurate. So now let's move towards the smart library kiosk which is built on ESP32-S3 Box 3. So this is the ESP32-S3 Box 3 which act as the brain of the entire system. It handles the user interaction, communicates with the backend server, controls the smart tracks and manages all book related operations such as searching, issuing and returning. The user interface (UI) of this kiosk has been designed using SQLite Studio and later integrated with APIs and backend logic to make it fully functionable and interactive. Whenever the ESP32-S3 Box 3 is powered on, it begins with a clean and visually appealing loading animation, giving the system a polish and a professional feel. Once the loading process is completed, the home screen appears, which acts as the main interface of the smart kiosk. This screen displays the Find My Book logo and presents the user with four more main options. Let us now go through each of these options one by one and see how the system works. So when the Find Book option is pressed, a search interface appears on the screen. Here the user can enter the book name or any relevant keyword. Once the search is submitted, the request is sent to the backend server and the system fetches the matching book details. After that, a details page is loaded, displaying complete information about the book, including the book name, book code, availability status, and the physical location such as rack number, left or right side, row number, and column number. In addition to this information, the details page also provide us with four interactive options. These are Blink Rack, Blink Book, Location Map, and Open on Phone. Let us go through each of these options one by one. As the name suggests, the blink rack option activates the LED strip on the corresponding rack, making the entire rack clearly visible to the user. This helps the user to quickly identify the correct rack from a distance. Next, we have the blink book option. When this button is pressed, the LED located exactly above the book's position starts blinking, clearly highlighting the precise spot where the book is kept. At the same time, the same LED color is also displayed on the screen of the ESP32-S3 Box 3. This makes the identification of the book even faster. Next, we have the location map option. When this option is selected, a visual map image opens on the screen. This image shows us the relative position of the user and the selected book, clearly indicating where the user is and where the book is located inside the library. To make the navigation more accurate, the system uses four different map images which are displayed dynamically based on the rack in which the book is located. After that, we have another very interesting feature called Open on Phone. When this option is selected, the ESP32-S3 Box 3 displays a QR code on the screen. Scanning this QR code opens a dedicated website page on the user's phone. This page is cleanly and thoughtfully designed and displayed the book cover image along with complete book details such as book name, code, and availability status. In addition to this, it shows the location of the book and it have the three interactive options: Blink Track, Blink Book, and Open Location Map. These control works exactly the same way as they do on the kiosk, allowing user to continue navigating and locating the book directly from their phone in a smooth and seamless manner. Now that we have completed all the features of Find Book, let's move back to the home screen. The next option available here is Issue Book. When the user selects Issue Book option, a new screen appears with the message, "Please scan the book RFID." To proceed, the user need to take the book and scan its RFID tag using RFID scanner placed next to the ESP32-S3 Box 3. Currently in this setup, we are using an external Arduino to read the RFID data and transmit it to the ESP32-S3 Box 3. Earlier, this RFID scanning was working directly on the ESP32-S3 Box 3 itself. However, after some library updates, we face compatibility issues. To avoid those issues and ensure stable operation, we shifted the RFID scanning part to an external Arduino. So once the book RFID is successfully scanned, the user verification screen appears. On this screen, the user is required to enter their enrollment number, which is provided by the college. After entering the enrollment number, the details are sent to the backend server and the system moves to the confirm issue screen. The confirm issue screen displays all the essential details related to the transaction. This includes the book name, book code, username, and the due date, which are fetched back from the server. The due date is automatically generated by the backend server and is currently set to 2 weeks from the current date. This duration can be easily modified based on the library rules, but for now it is fixed at 14 days. At this stage, the user need to click on the confirm issue to proceed further. An OTP verification screen appears with a message asking the user to enter OTP sent to their registered email ID. This email address is fetched by the backend server from the database using the enrollment number entered earlier. This email contains the book name, book code, due date, and the OTP required for the verification. If the entered OTP is correct, the verification is successful and the book issued screen is displayed. If the OTP is incorrect, the system immediately prompts an incorrect OTP message preventing unauthorized book issuance. So that completes the issue book process and the book is now successfully issued. Let's move back to the home screen once again. The next option available here is return book. When the user selects the return book option, a simple screen opens with the message, please scan the RFID of the book. To return the book, the user just need to scan the RFID tag using the RFID scanner placed next to the ESP32-S3 Box 3. Once the RFID is scanned, the system takes a moment to process the request and then automatically marks the book as returned in the database. No additional steps or verification are required. After the return is completed, a confirmation email is sent to the user's email address informing them that the book has been successfully returned. This makes the return process quick, contactless, and completely hassle free for both user and the librarian.
Further, I have also integrated a voice assistance feature into the system to make the interaction more intuitive and hands-free. Currently, due to some microphone related issues with the ESP32-S3 Box 3, I am using the microphone from my mobile phone for the voice input. The system listens for the wake phrases like "Hey Smart Library," and once the wake command is detected, it starts processing the user command and performs the corresponding actions automatically. For example, a user can say, "Hey Smart Library, find a math book," and the system will directly open the book details page without manually navigating through the interface. Similarly, the user can also use voice commands for issuing and returning book. For example, they can say, "Hey Smart Library, issue book," and it will open the issue book screen. And similarly, by saying, "Hey Smart Library, return book," it will open the return book screen, and after that the user simply continues with the normal process such as scanning the book RFID and completing the verification steps, and the system proceeds with respective functions as explained earlier.
Let's now look at the anti-theft and exit security system of the library. This system ensures that books are not taken outside the library without a proper authorization. At the exit gate, an RFID scanner continuously monitors books passing through the door. If someone tries to take a book outside the library, the system immediately checks whether that book has been issued or not. For demonstration purpose, let us consider two books, an English book and a math book. The English book is issued while the maths book is not issued. When an issued book passes through the exit gate, the system allows it and activates a green light along with a short buzzer beep indicating a successful and authorized exit. However, when an unissued book is taken towards the exit, the anti-theft system is triggered. A red light warning starts blinking with a buzzer alert, clearly indicating an unauthorized attempt. This mechanism helps prevent accidental or intentional book theft and ensure that only properly issued books can leave the library. To give a proper alert of theft, in one of the previous version I had added a audio like this.
Warning. Book theft detected. Book theft detected. Security alert activated.
Which was planned to be played on ESP32-S3 Box 3, however it was later removed to comply with the library standards and regulations. So now let's just move towards the final section of the video, the backend system and the database architecture. So for this video, I'm using a Raspberry Pi to deploy my backend, which basically runs a Flask server on this. Through this server, all the web interfaces, APIs, and the inter-device communication is handled smoothly. Along with this, Raspberry Pi also hosts SQLite database, which basically stores and manages all the data which is required by the system. Along with the backend, the project also includes an admin portal for Find My Book. This portal gives a read-only system overview where librarians can view book types, book copies, and their real-time status. It also displays complete user information and detailed issue and return logs, allowing easy monitoring of the entire system from a single dashboard. So that's all from my side. I hope you enjoyed the project and found it interesting. Thank you so much for watching.